Good morning, ladies and gentlemen. Welcome to the third edition of the International Conference on Virtual Reality. My name is DURSUN Akaslan. I am working in the Department of Computer Engineering in Haran University since 2014. Today, I am going to talk about perspective and non-perspective cameras in virtual worlds. Cameras are known as a device for taking photographs or making films or movies, or even television programs in the real world. Similarly, we also use cameras in the virtual world to define which portion of scene is visible in the render image. Because cameras are invisible in renders, they don't have any material or texture settings because for this reason we don't cover them with colors or patterns. We just use the camera to get the objects in the render image. There are many types of camera views in the virtual world. A scene and a camera is passed to a renderer. The renderer draws the portion of the three-dimensional scene that is based on the view of the camera as a 2D images. Today, we use many types of cameras, but the most common cameras in the virtual world are perspective and orthographic cameras. The perspective cameras are known as a perspective camera, where orthographic cameras are described as a non-perspective cameras. We will look at the details of this type of cameras. First of all, let's try to understand what is a perspective camera is. The perspective camera is the first most common camera in the virtual world because it gives a 3D view where things in distance appear smaller than things up close. This is the most common camera because it is so similar to the way humanity look at the object around. The perspective camera defines a frustum, which is known as a solid pyramid shape with the tip cut off. Can you say this is a kind of frustum? There are some settings we need to think about when we use perspective camera in the virtual world. There are four parameters. For example, the first one is near. It defines where the front of the frustum starts, as you see in the shape of the perspective camera. Can you see this is camera? This is the frustum. The far here, this is near, this is far, click plane. It also defines where the frustum ends, like this. Also, the third parameter is field of view. It defines how tall the front and back of the frustum are by computing the correct height to get the specified field of the view at the near units from the camera. And the final parameter is called aspect. It is used to define who divide the front and back of the frustum are. This is the perspective camera settings. The second most important camera is orthographic camera. It is a non-perspective camera because it has no perspective. It is the it's called orthographic camera because it has no perspective like frustum. It specifies a box actually rather than frustum, but we can call it as a frustum as well. It is projecting a box because there is no perspective. Let's look at details for the settings of the orthographic camera. An orthographic camera specifies a box, as we said, with the settings left, right, top, and bottom, and additional near and far. Can you see we are just drawing a box like, but it has also near and far clip plane. But can you see there is no perspective? Now, in order to understand the difference between perspective and non-perspective, namely orthographic camera, projection of views in a virtual world, let's do something practical in Blender first. This is a Blender. Can you see there is a cube in the scene? In the center of the scene, there is a cube, but we can add more shapes to the scene. I just click add button and I'm adding cylinder, one cylinder and one cone. Can you see there are three objects in the scene now? Cone, cube and cylinder. Let's change the location of these objects. First of all, I am moving the cone. Second, I am moving the cylinder. Let's set the 10-meter far from camera and also let's say 10-meter close to camera. Can you see there are three objects? Now let's focus on this object. Now we are in perspective mode. This is perspective mode. Can you see the cube which is near to the camera looks like bigger than cylinder, but actually their size is similar. But and look at this one. Can you see? Because we are in the perspective mode. Can you see? Cone is bigger than cylinder. But when we change it, can you see? Now its cylinder looks like bigger than cone because we are in the projection mode. But when we change the projection mode to orthographic, can you see? All the object in the scene looks like similar size. Can you see? But I can change the view. Now I am in the front. I am in the right. I am in the bottom. But when we change the mode to, can you see? There are some changes even in the top perspective. This is an example how camera view affects the size of the object. Let's do another practical work. In 3GS, can you see there are three objects? One cylinder, one cube and one cone. Just I am moving and zooming in and zooming out. Can you see? The cylinder looks like bigger now because it is so close to the camera. But when I rotate the objects, can you see? I am rotating. Can you see? The cone it looks like bigger now because we are in the perspective mode. But actually I'm not changing the size of any objects. Just I am moving the location of these three objects because in perspective mode. Let's try to change the sum codes. I have a scene. Can you see? I just created a new scene and I have perspective camera. In the field of view is 90 degrees now. I have renderer. I have controls. I can control the object in the scene by rotating and by zooming and in and out. Can you see my first object is cone. The second object is box, and third object is a cylinder. Can you see I changed the location of these three objects in the z-axis, and also change the location of camera to ensure all the objects are in the view of the cameras. Let's change the camera to orthographic. I just changed the cameras. I refreshed. Now look at, I am moving and changing. Can you see I am changing and rotating all the object, but the size of the object has no effect because I am using an orthographic camera. But in the perspective camera, when I rotate the object near the camera looks like bigger, but in the orthographic camera, this is not a case. Let's change again to the perspective camera. Let's refresh the pages. Can you see now I'm in the perspective camera? When I change, when I rotate the objects, the object close to the camera looks like bigger. This is the difference between perspective and non-perspective camera. We have done some practical works to ensure we can understand the difference between these two types of cameras. As a conclusion, perspective and non-perspective cameras are the most common cameras in the virtual world with different purposes. Depending on the purpose of the games, we should select the right cameras, but commonly orthographic camera should be preferred in order to draw the up, down, left, right, back and front views of a 3D model. Perspective camera are the most similar to the way that humans look at the object around. That's why if we are designing a game, uh, like a character is following the camera or camera is following the character, that means in that case we should use perspective camera. In this slide I try to uh, focus on the difference between perspective and non-perspective cameras. This is a technical topic. If you have any questions about this presentation, please send me email to my official email address, DURSUN AKASLAN, my name's, @aran.education.turkey.